Good morning.
Good morning, sir.
How are you?
I'm good, sir.
You ready for the rumble?
Yes, sir.
All right. So just give the others a couple minutes to join. And then we start. Even though it's recorded, but I'm just gonna give them a minute or two. The others, all right? Too fast. All right, guys, let's begin. You can see the screen clearly and hear me clearly.
Yes, sir.
Yes, sir.
Good. Let's begin. All right. So this was our last activity on the screen, and I'm just gonna work through it today first to begin, and then we're gonna look on to do a few past paper questions to sort of tidy up this part of the quadratics. Tomorrow's class, we're focusing on this kind of last part that we have to do, which is simultaneous equations leading to a quadratic equation, and also finding a quadratic function given the roots. So that's going to be our focus for tomorrow, for this week coming up. All right, so in this question, we were given this graph. We are told that it is a sketch of the function f of x equals 2x squared minus 5x plus 2. So clearly that's a quadratic function, and we see it as a smile shape because it corresponds with the fact that the square term is positive. And then it points to these points A, B, C, and D. Those 4 critical points, and also this vertical line, which is also critical on quadratic function. And it says we have to determine the coordinates of the points marked A, B, C, D, and we are to give a name or phrase which is used to describe each point. All right. And the second part says we are to write down the name and the equation of the vertical line passing through the point B. So that is that axis of symmetry there. All right. So they want the name of the coordinates, or the coordinates, and I want to highlight the term coordinates, plural. So coordinates, we generally give coordinates in a bracket where we put the x, y, and the x and the y value in the bracket. And if it's the coordinates of P that I'm writing, I would maybe, for example, put a P in front of it like that. That's what we generally write coordinates. So we have to give the coordinates for A, B, C, and D, and the name for each one. All right, so let's go. So the first point we're going to look at is the point A. Let's do them in order. Let's do the points in order. So that point clearly is the intersection with the y-axis of the function. And so it is a y-axis intercept. And at that point, because it's on the y-axis, the x value is 0. And the y value will be the c value in the quadratic function, the c value right here, which is at 2. So the point is going to be A02 or 0C. Let's do it over here. So the point A is called the y-axis intercept, or the y-intercept. The point A is the intersection of the y-axis, which is called the y-intersect, or the y-axis intercept. So let's write it as the y-axis. Let's make this a little larger, a little brighter. Let's go again. So A, we're going to call it the y-axis intercept. And note how it is spelled, intercept. It's a point of intersection with the y-axis, but it's called an intercept. And the coordinates of that point A is always 0, and the C value in the... Mute your mic, please. Which then becomes A02. So this is the coordinates, and this is the phrase or the name representing A. And we're done with A. Simple as that. At the point A on the y-axis, x equals 0. If you put 0 here for the x and 0 here for the x, then the function value, which is also a y value, is going to be equal to 2. That's what we have here. All right, simple as that. Then we come to the point B. And that point B is a vertex of the quadratic curve. This one is a minimum, a smile-shaped quadratic curve, and so it's a minimum turning point, or the vertex of the quadratic function of that curve, which is a parabolic curve, which is symmetrical and has a turning point. In this case, the turning point is a minimum turning point. So let's start. So B, now we're going to talk about the point B. B in this case is a turning point, but we know it is minimum, so we can be specific and say it's a minimum turning point, which is also called a vertex. And whether it's a maximum or minimum, it's called a vertex. But when it's a minimum, it's called a minimum turning point. or maximum turning point. When you do maths at a higher level, they may also call it a stationary point. All right, but for now, we're just gonna call it a minimum turning point, which is a vertex. But they also want the coordinates. Now, the coordinates, as we put it in the class, we call it xt, yt. In other classes, person might refer to it as something else. For us, the t means turning point. So this xt means the x value at that turning point. And this yt means the y value at that turning point. And we can calculate those coordinates from the values in the standard form. Right? The A, the B, and the C from the standard form. Now this here is a standard form. And in this standard form, the A, which is the coefficient of the x squared, is at 2. So the A is 2. The B, which is the coefficient of the x, is a negative 5. You cannot ignore that negative. It's a negative 5, minus 5. And the C, which is a constant term in the standard form, is equal to a 2. So the A, the B, and the C are the constant values from the function that we're going to be using to calculate the coordinates xt and yt. There are other ways to do it, but we're going to do it using this formula method. All right, so let's go. So the xt that we want for here is equal to minus b divided by 2a. The a and the b, as I said, comes from the standard form of the quadratic function, which is what we have over here. So that becomes minus, that minus is this one that I've written down. Then the b itself is a negative 5. And so this becomes minus, and the b is a negative 5. I can put it in a bracket. So that's a minus b. And that minus makes that a plus on the numerator. Divided by 2 times the a value, and the a is 2. So this works out to minus, it gives me a positive 5, divided by 2 times 2 is 4. So that is the x value at the turning point. So that value, we're going to place it right here in the bracket for the coordinates. Then we need the y value at the turning point. All right. Now there's a formula that can be used to find the y value at the turning point. But another way to find the y value at the turning point, let's say we have the xt value here equals 5 over 4. Another way to find the y value, we can take this xt value and plug it for the x in the function. And whatever we get for that y value there, because remember the function is also a y value, you know, you're getting, you know. And whatever value we get there is also our y value at the turning point. All right, but then there's a formula that can be used as well, which is to say yt equals 4ac minus b squared divided by 4a. All right, and it's very good to learn these two formulae. So this is a must-know formula to find the x value at the turning point. That's a must-know formula to find the y value at the turning point. It will not be on any formula sheet in the exam. So if you're going to use this method, you have to learn these two formulae. All right. So let's go. So we're going to plug in the values now. So over here, we're going to write, and we're careful with this negative sign. You have to be careful with that negative. People make a lot of mistakes with that negative because they believe it is squaring. Let me say it from now. This minus is not squaring because we are only squaring the b. We're not squaring the minus. And so this minus remains unchanged, remains a minus because it is not squaring. A lot of persons believe it is squaring and change it to a positive. No. All right, let's put in the values. It is 4 times a. The a from over here is at 2. So 4 times 2 times c. The c is at 2 again. And then we are subtracting b, and the b is a negative 5. So we're subtracting a negative 5. I was squaring that. And you're dividing all of that by 4 times a. And the a again is at 2 right here. We can place that in the calculator and work it out. But let's work it down step by step so we can understand it. All right. So the y value at the turning point becomes, this is 4 times 2 is 8 times 2 more is 16. So this works out to 16. Minus, this minus is this one. And then this negative 5 squared. This negative 5 squared is the same as negative 5 times negative 5. Comes a positive 25. So I'm just going to write a positive 25 right here for this thing in the box. All right. So I've not changed this minus. It remains the same. All right. And then now we're going to divide by this 4 times 2, which is 8. And then we will simplify this. 60 minus 25 is negative 9. And you're dividing that by 8. And we can leave the values like this and place them now in this as coordinates. And so the coordinates here now of B, if we're going to write it, it means that B is the point. 5/4 is the x value at the turning point. And negative 9/8 right here is the y value at the turning point. And so that completes the work for B. All right, hold on a second. Somebody was calling me. I think it's someone from class. Let me just answer this quickly. All right, just excuse me a second, guys. Somebody was calling me from class. Let's answer this. Morning. No, but you call me when the class start. We are in the class. We try. It's extra. It's just extra, and we try to do it. There's no guarantee. All right. All right. Cool. All right, guys. Sorry about that. All right. Just wanted to make sure it wasn't a parent or a student having some problem getting in. All right. All right. So that covers the point A and the point B. So let me move this out of the way a bit from here, so we can have a focus on the diagram. I'll put it up here. All right. So the next points we need to find are the points C, mute the mic please, the points C and D. C and D, I'm going to find both of them the same way or at the same time because they are the roots. They are the x-axis intersect. And they are the points where the curve intersect the x-axis. So the same thing is happening at those 2 points. What same thing? The y value there is 0 at each of them because they are points on the x-axis. Once it's a point on the x-axis, the y value is 0. All points on the x-axis, y coordinate is 0. Mute your mic, please. Mute your mic, please. If you're not saying something, mute your mic, please. All right. So to find the roots, those points are called the roots. The x-axis intercepts are also called roots. I'm going to be doing both of them together. So we're doing C and the D, finding both of them together. They are the x-axis intercept. Somebody's mic is still open. Mute your mic. Just check and mute your mic for me, please. They are the x-axis intercepts, which are also called the roots. We refer to them as the roots. And to get those two values, we have to solve the quadratic equation. The equation that is associated with this function. Remember, somebody's still not muting the mic. Jesus. Hold on a second, guys. Let me see if we can get the mic muted. right, sorry about that. Sorry about that, guys. All right, let me try and monitor from here. All right. So remember that the function gives us the entire graph. This is a function. This is a function. It gives us the entire graph, gives us all points on the graph. But when we want the roots are the points where the y value equals 0. And so when the y value is 0, we end up with the equation, the quadratic equation. And we solve the equation when we want to find the roots. The roots are the x values where the graph intersect the x-axis. Those values are called the roots, or the values that you get when you solve the equation. So the points are called the roots, or the x-axis intercepts. But the x values that you get when you solve the equation are also called the roots. They are the roots of the quadratic equation. All right. So the word roots sort of have a double meaning there. So to find the roots, we're going to solve the equation which is associated with the function, which is 2x squared minus 5x plus 2 equals 0. So we are solving this equation now. That's a quadratic equation we need to solve. So we're going to be solving this equation. We have two options really. We can solve it using the quadratic formula, or we can solve it by factorizing. Now this one can be factorized easily because when I look at the n values, they are prime, and I realize that when I multiply them, I'm going to get a 4. 2 times 2 is 4. I'm sort of thinking ahead. And the factors of 4 are 1 and 4, and 1 and 4 add to 5, which is the middle term. Remember also that when the last value there is positive, it means that the two signs in the bracket are the same, provided the first term is also positive. It means that the two signs in the bracket are the same, and both of them will be negative. All right, and then now this minus 5x is going to be the sum of our far product and our near product. So because the n values are prime, we can do this without using this AC method where we multiply the a times the c and all of that. All right, so I'm just going to factorize it straight. Factors of the 2x can only be 2x and x. Factors of this 2 can only be 1 and 2. It's a matter of where we place them. Let's say we made a mistake and placed them in the wrong place. Let's say I put the 2 here and the 1 here. My far product would be 2x, and my near product also will be 2x. And this plus is telling me that I have to sum those two products to get my middle value. But 2x and 2x is 4x. My middle value is a 5x. So it means that I cannot use the 2 and the 1 as they are positioned right there now. I have to switch them around. Right? So these two values are not in the right place. I have to switch them around. So I have to put the 2 over here and the 1 there. Then you see that the far product becomes 4x and the near product is 1x. The 4x and the 1x, they add to the 5x in the middle. So it means that the values are positioned in the right place. Just a matter of the signs going in the bracket now. All right? So remember now that when the last value is positive, given that the first value is also positive, it means that the two signs in the bracket are the same, and this sign is what both of them will be. Both of them will be negative. Minus, minus. So that is a shortcut method of factorizing, especially when your n values are prime. It's a very good method to use. All right. So we now come down to this equation equals 0. The product of these two things equals 0. So remember, it is either this one that is equal to the 0. So let's write it out. It's either 2x minus 1 that is equal to the 0, or x minus 2 is equal to the 0. If I make x the subject of this one, what I would do is transpose the 1 over here first and get a positive 1 and then divide the 2 under it. And so, shortcut, the x is going to be equal to positive 1 over 2. That's one root. And the other root is going to be when I transpose this -2 and I get x equals 2. So those are my two roots. If you look at the graph now and make the points make sense. So the C point clearly is the one with the smaller root, or the root with the lower value. Most corresponds to the C, to the half. So it means that C is the point half 0. Half is the x value at C, y is 0 is the y value at C. And D now must be the one corresponding to the 2 because it is here. It is here. It is to the right of C. So it must have the larger x value. In this case, it is 2. And so D is the point 2, 0. And so those are my coordinates for C and D. So I've given the name and the coordinates for all the points, A, B, C, and D. So those are my answers so far. Anybody have any questions so far? Everybody okay?
No, sir. Yes, sir. We're fine.
Yes, sir, we're okay.
Beautiful, beautiful, like that. All right, so let's continue now and talk about this vertical line. And that vertical line we can see, and they actually said it, it passes through the vertex point. Now, the quadratic graph or the quadratic function, the graph that you get from a quadratic function is also called a parabolic graph. It's a parabola. It is a graph that is symmetrical, and so it has a line of symmetry. And this is a line of symmetry. Is that line divides a graph in two equal halves. One half is a mirror image of the next. And so, for example, what you'll find is that the distance, let me zoom it up and show you. The distance, oh, you can't zoom. All right, let me unlock that. And so, for example, what you'll find is that the distance from that line, and this is something that is important for you to know, it becomes relevant in some questions. The distance from the axis to this root is the same distance from the axis to this root. Same distance. And the same thing goes for any point that has the same y value. The distance from the axis to this point over here is the same distance to this point over here that would have the same y value. Those distances are the same. The graph is symmetrical about the line, about that vertical line which passes through the vertex. Remember, the vertex, we worked out the coordinates. It was 5/4, -9/8. All right. So this vertical line has an equation. This vertical line, which is a vertex line, the axis of symmetry, I mean, or line of symmetry, it has an equation that is similar to the equation of the y-axis because it is vertical like the y-axis. The equation of the y-axis is x equals 0. My mistake. X equals 0 is the equation of the y-axis. So this vertical line carries an equation similar. X equals some number. So because that line passes through a point where the x value is 5/4, it means that the equation of that line is x equals 5/4. Because all points on this line, the x value will be 5/4. Just as though all points on the y-axis, the x value is 0, hence the equation of the y-axis is x equals 0. Then the equation of this vertical line is x equals whatever the x value is at that point. All right, and so that answers that one. So let's write it down. The vertical line is called the axis, or sometimes called the line of symmetry. Now, some people spell symmetry with 2 M's, doesn't matter. 1 M or 2 M, depending on whether they're using American spelling or the English spelling. And sometimes in CSEC you see the word symmetry with 1 M, sometimes you see it with 2 M's. All right. So the axis of symmetry is the name of that line, and the equation is always x equals whatever the x value is at the turning point. So because we know that the x value at the turning point is 5/4, it means that we can write it and say that is the x value at that, the x value, the equation of the axis of the line of symmetry, the equation of the line of symmetry or the axis of symmetry is x equals 5/4. This is the actual equation of that line that I've written. This is the equation of that vertical line. This is the equation of it. X equals 5/4. All right. So that basically finishes this question. That finishes that question. Everybody okay still? But all right?
Yes, sir.
All right, good. Let's jump down to here now. We have some factorization to do as well. We have some factorization to do. So we had this first thing to factorize right here. I see 4 terms there, so I'm thinking it's the factorization by parts, or we call factorization by grouping. So normally when you're factorizing by parts with 4 terms, you normally want to set out the values in a way that is friendly to the process. All right. So you sort of think ahead, or you sort of take a few steps ahead in your mind to see if the values are set out in a friendly manner. If they're not set out in a friendly manner, you have to rearrange the values sometimes to make them be be in a order, or in a friendly order to the process. So when I think of the first 2 terms, and if I were to factorize the first 2 terms, I will get 3 into g minus t. So I'm really looking for the g minus t over in these 2 terms now to see if the g and the t are in that same sequence, the g and the t, which they are. The g comes first and the t comes second in those 2 terms. And therefore, you see that they are in a friendly order. And so there's no need to rearrange the values, and I can proceed with the factorization. And so I have 3g minus 3t plus 2mg minus 2mt. And so I'm going to use a process where I ensure that I have the same thing in the 2 brackets, right? So I can get a 3rd line in the factorization. So the highest common factor in these 2 terms is 3. 3 out of this leaves me with a g. 3 divided out of this leaves me with a negative t. And because I checked and I realized that I have the g minus t and they also have a common factor of the 2m, what I'm going to do is put back the g minus t over here first. Then I'm going to check. If I were to divide this g by the plus 2mg, then I will get a plus 2m out here. Similarly, if I divided this minus 2mt by this minus t, I will be left with still again a positive 2mt. And the key thing always remember, you must have plus or minus some value out here. You cannot just put a value. In this case, it is a plus 2m. I don't want you to just put 2m. And then what happens now is that this g minus t becomes our common factor on the next line. And so it is 3 times the common factor plus 2m times the common factor. And so it's like we're putting these 2 by the distributive law together, multiplying by that common factor. So it's like you have 3 apples plus 2m apples, giving us 3 plus 2m, and your opposite would be g minus t. Utilize, please, cannot be factorized any further. All right. So basically, that is the answer right there. Factorize completely. Okay, let me take out these red lines. And then part B now was first to factorize this thing. All right, which is 3x squared minus 3. But all these questions come off past papers, you know. So yes, they set simple questions like these and past papers. So when I look at it, the only common factor I have initially is 3. Is 3. All right, I'm thinking about the difference of 2 squared, but that's not a perfect square. So I'm not going to work at the difference of 2 squares just yet. I'm going to do the common factor first, which is 3. When I factorize 3 out of this, I'm left with x squared I'm going to factorize 3 out of this. I'm left with -1. And then I look inside here to see if it can be factorized any further. And yes, it can be factorized further because we have to know about the difference of 2 squares. And 1 is a perfect square. We have to remember that 1 is a perfect square. So this can be written as 3 into x squared minus 1 squared. 1 and 1 squared is the same. 1 is the perfect square that a lot of persons tend to forget about. But remember 4, because 4 is 2 squared. Remember 9, because 9 is 2 squared, is 3 squared. And remember 16, because 16 is 4 squared. And remember 25, and remember 36, and remember 64 and 81 and all those. But for some reason, people tend to forget 1. Yes, 1 is also a perfect square, just that it is still 1. All right, so when we apply the rule for the difference of 2 squares now, don't throw away this first factor. So put by the 3. And then the rule is that it becomes the difference of the 2 values, which is x minus 1, times the sum of the 2 values, which is x plus 1. And basically, that is it. That's the answer right there. All right, so we'll factorize this. We get this, the difference of 2 squares. That is in the bracket. That's what we get. All right, so we spoke about the rule for the difference of 2 squares in class. All right, so let's continue. Then we come to this last question down here, number 3, which basically says we are to solve this, and that's a quadratic equation in a basic form. Remember, we have to put it in a standard form before we try to solve it. Standard form is when the quadratic expression is equal to 0. That's the method we're going to be using to solve it. Why? Because the quadratic formula, for example, was set up around the quadratic expression being equal to 0, the equation being in that form. And if we're going to use factorization, again, we want to use a special property of 0, which is that if if the product of 2 numbers is equal to 0, then one of those 2 numbers must be 0. One or the other must be 0. All right. But this question gives us an additional line, which is to say we are to give our answer correct to 2 decimal places. Now, why is there the need to tell us that? They are telling us that because we are not going to be able to use factorization to solve that equation. It's almost like a hint that we are to use the quadratic formula. Don't bother try to factorize it. Just use the quadratic formula. Remember, the quadratic formula can be used to solve all quadratic equations that are in a standard form. All of them. The factorization, you have to be able to do maths at an advanced level to use factorization for some of them. So for CSEC level, based on the method that we use for factorizing, you can do some of them by factorization. Right? So this is one, and this is why the question is written like this, telling you the level of accuracy you must use for your answer. Once you see a quadratic equation asking you to give a certain level of accuracy, it is basically because the answers are not exact, and you won't be able to do it by factorizing, and so you're going to use a quadratic formula. All right, you're going to use a quadratic formula. You can also do it through completing the square now, but then the quadratic formula was derived through the process of completing the square. So it makes sense to just use the quadratic formula because this is not forcing you to use any particular method. And so you're going to be using a quadratic formula. Don't try to factorize it. You cannot factorize it. All right, so that I've underlined is red is almost like a hint to say use a quadratic formula. Let me write the quadratic formula here. It is that when the equation is the form ax squared plus bx plus c equals 0, when your quadratic equation is in that form, the x is equal to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Now this all over 2a is very important because a lot of students make the mistake and put the 2a over here alone and actually square root it like that, which is wrong. All right? It is everything over 2a. Remember, this is very important. So to ensure that it is everything there must be divided by the 2a. That is the formula when you write it out properly and execute it properly. All right. So this equation, we need to transpose it over into the standard form by moving the 6 over here and leave 0 on the right side. So let's write the standard form for it first. So we're talking about question 3. When we transpose the 6, we're going to get 3x squared minus 5x, and the 6 goes over and becomes a negative 6 equals 0. Because we have done that now, we have the equals 0, we are now able to identify the a, the b, and the c correctly. The a is equal to the coefficient of x squared there, which is 3. The b is the coefficient of x, which is this negative 5. I have to carry the negative with it. And the c is a constant term in the expression. The constant term right there is a negative 6. And again, we're using this formula. So we're dropping the values in that formula right there. Let me just start right away then. It means that our x is equal to minus, that is this minus I'm putting down first, that minus. And I want to put down b. But what is b? b is negative 5. So that becomes a minus negative 5. We can put it in a bracket. Then we'll come to the plus or the minus. The square root. And then we're squaring b. b is negative 5. So I'm going to put negative 5 and put the square on it. So when I square this negative 5, it's going to become a positive 25. All right. Then I'm going to put down this minus. So I'm putting down minus 4 times the a. And the a in this case is a 3. So put a 3 in bracket for the a. Times the c. Oh, I made a mistake. The c is actually negative 6, not 6. My mistake that. See? Well, being able to see a mistake is also important. All right. So the c is not 6, it's actually negative 6. You have to see that. You have to carry the sign with it. And so I'm putting the negative 6 inside here for the c. All right. So let's do that now. So this is a negative 6. And then now we're going to put everything over the 2 times a, which is 3. And then if you have a good calculator, you can type that in exactly as it is and give you the answers. Well, it works this out for you, but work out the values for you. But let's go on and simplify it. So the x equals, this minus minus makes this a plus 5. Plus or minus the square root. Remember now, this negative 5 squared is the same as negative 5 times negative 5, which gives us a positive 25. We're going to be careful with these negative signs now, negative and negative. So the negative 4 times the 3 is negative 12. So this is like negative 12 times negative 6. Negative times negative is a positive. 12 times 6 is 72. So we get a plus 72. Dividing all of that now by 2 times 3, which is 6. So these two add now to 97. So this reduces to x equals 5 plus or minus the square root of 97. Everything divided by 6. So we're going to get one of the roots, or one of the x values, one of the solution values with the plus. We're going to get the second one with the minus. So let's write them out. The first one we're going to use with the plus. So it's 5 plus root 97 divided by 6. Or the other one with the minus. X equals 5 minus root 97 divided by 6. Now, some calculators, you can type this in exactly as it is, and you can look at it like that. If you don't have one of those calculators, a safe thing to do is to bracket the numerator before you divide by the 6 to ensure that you're dividing the entire numerator by the 6. All right? Or what you can do is work out the numerator value first and then divide by the 6. Let me bring up a calculator. Let me bring up a calculator to do it. Put this over here. And let me bring up a calculator to do this. Let me bring up a calculator. What's that one on the screen here? All right. Where are you? Good. I'm just going to illustrate it for these two. So I'm going to set up my fraction, and you need to get one of the calculators that will show you this. 5 plus square root 97 over 5 over 6. And my answer there is 2.47. All right, so I'm getting x equals 2.47, or x equals, I'm going to change this plus to a minus now. Change that plus to a minus, and give me negative 0.81. Remember, I wanted two decimal places. All right, so I'm going to get negative 0.81. And those are my two answers right there. All right, everybody okay with that?
Yes, sir.
All right.
Yes.
All right, good. All right, so from here now, what we're gonna do, we're gonna look at some past papers. Practice some more quadratics, right? Look at some past papers. Let's look at 2023 this year. Let's look at 2023. Let me search for it. 2023. Let's search for it. 2023. 2023 this year. Where are you? Supposed to be here somewhere. Right here. All right. So this is it. 2023 this year. I have to draw a graph. Let me split the screen and bring up a second one, so we can have one with the graph by itself. So let's look for it here again. June 2023. Let's bring up a second one, so we can use one as a graph. All right. So there was one on the June paper this year, guys. Just go and see June 2023. And June 2023, and this is a question. Question number 8. Question number 8. See there? Question number 8. All right, so I'm gonna use one side for the graph and one side for the calculations, right? All right, let's go. Let's practice some more of these questions so we can understand it. And when I send the video, I want you to redo the questions, all right? Do them again. More maths equals better maths. All right. All right. So the first part of the question, it gives us this quadratic function, right? Look at it carefully. So see the x squared term is negative. So it's going to produce a round shaped graph. All right. So it's going to have a maximum point, because it's a frown. And it gives us this table with some of the values. Remember, the graph is a symmetrical graph, you know? So sometimes you actually don't have to work out all the values. You can look for the symmetry on it. All right. All right. So this one, maybe we have to work out some of them, but sometimes as soon as you find one value, you're good. All right. So we need to work out for -3, for -1, for 1, and for 3. We need to work out those values. All right. I'm going to work out for the -3 first. How do we get the value for the -3? By plugging the -3 for the x in the function. That's all we have to do. Let's work it out over here. So when x equals -3, talking about this point, when x equals -3, y becomes minus, look carefully now, guys, becomes minus, that is this minus. I am only squaring the -3. So this minus stays a minus. I'm squaring that -3 plus a -3 again. But plus -3 is the same as -3. So I can just write, let's write it plus -3 for the x, and then +7. All right. So this becomes equal to, you can put that in the calculator, but look, this becomes -9 because this works out to 9. And then this plus minus is going to give me -3. And then I'm going to be adding back this 7. So this works out to be -5. But that's a -12 plus that is -5. I'm going to get -5. I'm putting -5 right here. And I see that I also have a -5 over here. So look, I can put in some of the values now. Remember I said that the graph is symmetrical. Now all these values on the x value, on the x-axis are the same increment, the same one between them. There's no change in the increments. One there, so, 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 one there, so. X value is increasing by the same amount. Remember the graph is symmetrical enough. Now, since this value is a -5, when I come in 1, it drops down to 1. So when I come in 1 this way, it must also drop down to 1. And then now, I look now from the 1, and this side I come in 1, it drops down to 5. So when I go in this way, this also must drop down to 5. And then from the 5, when I go in 1 more, it drops down to 7. It increases to 7, not drop down, goes up to 7, goes up. I'm using the wrong word, but from -5 to 1, from 1 to 5, from 5 to 7, and so when I come in this way, it's going to go to 7 as well. So those are my values, I really don't have to work out all of them, Why? Because I know that the values are symmetrical, about a line of symmetry. Those are the values, Once I pick up this -5, come inwards, I go to 1, come inwards, you go to 1. Come inwards, this way, you go to 5, come inwards, you go to 5. Come inwards, this way, you go to 7, so you must go to 7 there as well. And I can work out the values and prove that that is correct. Right? I don't want us to just know how to do stuff. I want us to understand it because the graph is symmetrical. So I can work out this -5 and show you that is actually -5. Let's work it out. It is when x equals -1. So let me just work it out for you. When x equals -1, y equals minus a -1 squared, a -1 squared, plus a -1 plus 7. This is going to become a -1. This is going to become a 1. This is going to become a 1. And this minus is not changing. So this works out with -1. This again is -1. And you're adding 7. This is -2, That's -2 plus 7 is 5. So you see this works out to 5. The same 5 that I have there. I did not have to work it out because I pick up the symmetry of the function. All right. And if you want me to work out the 7 right here to show that it is 7, I just need to put x equals 1 in there again. All right. So when x equals 1, I'm going to get y equals -1 squared, because remember the x is just 1 here, so now. Plus this 1 and plus 7. Then this -1 squared just becomes a 1 squared. So it always becomes -1 because this 1 squared is 1. This minus is not changing. It stays a minus. Then you add this 1 and plus back this 7. This -1 plus 1 wipes out each other. And you're left with this 7. So you see, this 7. When the x is 1, the y is 7. And I can prove that when x is 3, this works out to be 1. When x is 3, the y is going to be -3 squared. See, we're using this function right here. This minus is not squaring, and you're squaring the 3 on the x. -3 squared plus 3, and you're plussing the x here. You're plussing the x, and you're adding back 7 again. Plus 7. This becomes -9, but you're only squaring the 3. This minus is not changing. And then you're adding 3, and you're adding 7. This 3 and 7 is 10. 10 minus 9 is 1, equals 1. So you see there? Then x equals 3, y equals 1. And x equals 3, y equals 1. But I showed you that I could get all of these. I could get these 3 values after I got this one alone by observing the symmetry. The fact that the quadratic curve is a symmetric graph. Now, let me explain something to you right off the bat now. Right? This graph has a front shape, so it's gonna have a maximum point. I will say a semi here and a semi here. The maximum point is one maximum value. Remember, the maximum value is the highest y value. So since 0 is taken up to 7, 0, x value of 0 is given a y value of 7, and the x value of 1 is given us a y value of 7. It means that your line of symmetry is exactly between here. That's where your line of symmetry is. That's the line of symmetry, you know? Right between the 0 and the 1. So I know off the bat that the line of symmetry is the value that is halfway between 0 and 1, which is a half. In this case, my axis of symmetry, without calculating anything, is going to be x equals a half. And my maximum value, I can get it by substituting the half in the function. I can show you that my xt value is going to be a half if I use the formula minus b over 2a. Right? And I know that my yt value is going to be a value greater than 7. Some value that whatever I get when I plug a half in there. Right? If I look at the sketch, it's almost like, make another sketch and show you what I'm saying. I'm doing this, guys, because I want us to understand it. Not just work the numbers. I want us to understand the function fully. So it is like this point here is the point 0.7. And this point across here is the point 0.17. And the graph goes further up in between them, up to here. And that is the maximum point. And it is at a point, and this is the line of symmetry. Now, because this x value is 0 and this x value is 1, the halfway mark between 0 and 1 is a half. So right here, the x value is a half. It's just a matter of working out the y value now. Y value at the turning point. So I already know where the axis of symmetry is. X equals a half. Think you understand that, guys? Think you understand that?
Yes, sir.
All right, let us continue and show. Let's answer the question. But that is the table completed, guys, and realize I did not need to do these calculations. Notice I did not need to do those calculations. I use the symmetric nature of the quadratic function to get the values. Once I pick up the -5 and the -5 here, it means that the values become the same as you go inward this way and that way. Understand? Once these x values are in the same interval, they're increasing by the same amount. Once x values increasing by the same amount, the y values will be symmetrical. They will be symmetrical. I want you to watch over this video. Make sure you understand this. These things make these questions easier to do and also easier to understand stuff that you might need to do. All right. So I want you all to make sure you watch over the video and look back at what I did. Because as I'm saying to you, I did not have to calculate these. I did not have to calculate those. All right, good. All right, so let us look at the next part now. The next part wants us to put the points on the graph and draw the graph. All right, so let me, since I have the values on the table over here, let me bring up the graph on the right side. I'm going to put down the points and draw the graph. All right, so this time, students, we're not sketching. We are drawing a graph on graph paper. So accuracy now is important. You have to be accurate now. Put the points at the right place and draw a curve. Do not put any ruler on the quadratic graph. There are no straight line sections on it. It's a curve. It's called a quadratic curve. So do not put any ruler between the points and draw a straight line between the points. No ruler should go on any part of a curve like you're drawing a part of the curve with a ruler. It must always look like it's a curve. Just sketch it the best curve you can sketch through the points with your free hand. All right, let's put on the points. The first point is -3, -5. From here, -3, -5. So that's negative 3 out here. Negative 5 is here, so we're coming down to negative 5. So we're talking about this point right here. Negative 3, negative 5 is that point. But I can argue with that. That point is negative 3, negative 5. Right here. Negative 3 is the x value. This way, negative 5, you come down to negative 5. See there? I want to make sure you all understand that, agree that this is negative 3, negative 5, this point. But okay with that? Somebody open the mic and let me know, please.
Yes, sir.
All right. The second point is negative 2, 1. Negative 2 is the x value, 1 is the y value. So see here, negative 2, and we're going up 1. So 1 there, we're going up to 1. So we're talking about this point right here now. You have to plot the points correctly. That is a point. The next point is negative 1, negative 1, 5 right here. Negative 1, 5. Negative 1 is the x value, 5 is the y value. So negative 1, and we're going up to 5 right up here. 5 there. So we're talking about this point. That's the point we're talking about. But I agree with that? But okay with that?
Yes, sir.
The next point is 0, 7, because remember it's a y-axis intercept, 7. So it cut the y-axis at 7. 0, 7 is right here. All right, let me not cover the 7. I wanted to show right here. All right, the next point we have is 1, 7. But we do have the vertex point, you know. You must know that there's a vertex point. If you understand the quadratic graph, you will know that there's a vertex point that is higher than the 7. The maximum value is more than 7. The maximum value does not occur at 2 points. So 7 is not the maximum value. The maximum value is higher than 7, more than 7. If you understand the quadratic graph, the maximum value is 1 value occurring at 1 point. All right, so we're gonna put in the 1, 7 for now. So 1, 7 is right here. The next point is 2, 5. 2 coming up to 5. So you see the y value is coming by the same y value across here. 5. The graph is symmetrical. The next value is 3, 1. See 3, 1. 1 coming back again. 3, 1 right here. 3, 1. The next value is 4, negative 5. 4 and come down to negative 5 right here. But I give it that.
Yes, sir.
And we can
Yes,
see that
sir.
there's a line of symmetry right in between the graph them. That's a line of symmetry. The distance from the symmetry line to this is the same as to this. The distance from the line of symmetry to this is the same as to this. The distance from the line of symmetry to this, same as to that. Same thing only from the line of symmetry to this, same as that. Because those points have the same y value. That red line in the middle is our line of symmetry. The maximum point is on the line of symmetry. So if you're going to draw the curve and you don't recognize that the graph must go above here, some persons might do this and then try to come straight across here and then do that. And if you do this, it is wrong. It means that you don't understand the quadratic function. The maximum value is not 7. It has to be a value higher than 7. The maximum value is 1 y value. So that y value, the maximum point, occurs only 1 time. And to find that maximum value, what we can do, because we recognize that the maximum is at the point where x equals a half, in between here. All right, and a student with advanced knowledge, see, this is x equals a half, you know, see there? Axis of symmetry, this is 0, this is 1, right here is a half. X equals a half is that line. We can find that maximum value by putting the half in the function and see how far up we need to bring the graph. And we see how far up We need to bring the graph. How far up here we need to bring the graph if we really want to be accurate and do it like we understand and know this thing. So I'm going to work out the maximum value. And I'm gonna do the calculation for xt and show that is the half, and show you that I could have used that same half in the function. We're doing some extra work on this so we can understand it. All right. So I'm gonna put in the xt first. Let me calculate xt first, as if I didn't know it's a half. Now in the function, it is y equals minus x squared plus x plus 7. That is what we get. That, right? Plus 7. Marker giving me some problems. All right. Now in this, if this is the function, right, then the a will be equal to -1, the b will be equal to 1, and the c will be equal to 7. If you calculate xt, x by the turning point, which is minus b over 2a, it will be minus the b is 1 over 2 times the a is -1. This will become -1 over -2, which you see is a half. But I didn't have to calculate it because I have the values there. I can see that that is the x value turning point. And then, as I said, I can take the x value turning point and put it in the function, or I can calculate yt. Whichever way you do it, you're going to get the same answer. I'm going to do it both ways just to show you. All right? I'm going to do it both ways just to show you. Let me make this a little bit smaller. The thing that we never really need. Let's make it smaller. So I have more space to work. Let's make this smaller. We never really need that. All right? And shift this up. So we're just doing some additional things with the question, guys, because I want us to understand it. All right? I want us to understand it. Let me just answer this call and see if it's something relating to the class. Hold on. Hello? Yes? All right. You can call me back about 2 o'clock, please. I'm in a class now. 1:30. Yeah, man, no problem. Cool. All right, sorry about that, guys. All right, so I can calculate the yt and show that's a value greater than 7. So we can calculate yt the normal way. Yt equals 4ac minus b squared divided by 4a, which becomes 4 times the a is -1, times the c is 7, minus the b is 1, I'm squaring it, divided by 4 times a, and the a is -1. If we work that out, this becomes 7 4 is 28, become -28, and -1 given -29, minus 29 over -4, which becomes 29 over 4, which really is 7.25. So you see more than 7, the 7.25 is the yt value. 29 over 4 is 7 remainder 1 over 4, 7.25. So the maximum value is 7.25, more than 7. And I tell you, you can try it for yourself. If I plug a half for the x inside here, you're going to get the same thing, 7.25. You can try it for yourself. All right. So I know that my maximum point is at 7.25. I'm going to put it in red over here. So let's look at 7.25. Let's sort of estimate it. So this is 7 and this is 8. So 7.5 will be right here. That will be 7.5. So 7.25 is halfway between 7 and 7.5, which is about right here. So my maximum point is right there, so which is about right here. So I have to make the graph go up to that point. That is my maximum point. Coordinates, half, and what was it? 29 over 4, which is 7.25. That is that point. 29 over 4 is 7.25. So when I sketch the graph, I have to make sure it come up to here. That's what the students who understand this thing will do. And I want my students to understand this thing. Right? Understand it. So I'm going to sketch a graph now. That's a nice, very smooth curve I can draw my free hand. Let's go through the points like that. Make sure it go up to that maximum point, come back down. And then you just come through these points here. And you go like that. Draw that on the exam and CSEC will give you your marks. Any questions on that?
No, sir.
All right. So make sure we understand that maximum point. So you see, there was no indicator for us in the question so far when they told us to sketch a graph that you needed to go above the 7. But if you're on it, you are expected to understand the quadratic function to that level to know that there's a maximum point. So 7 cannot be a maximum value. The maximum value of y cannot occur at 2 different points. All right, and you also understand the symmetric nature of the graph. So the maximum value was at a point half between the 0 and the 1, where x equals a half. All right, but the values are divided symmetrically about that line, x equals a half. All right, so let's continue. That's what they wanted us to do down here. This one says, write down the equation of the axis of symmetry. See it? X equals a half. Because you understand the quadratic graph, you can just write down these things now. It's x equals half. That's the equation of that line, that vertical line. This line they're talking about now, you know. This line. Vertical line that passes through the turning point. See there? That line is the line x equals half. And below the graph, they wanted us to write down the coordinates of the maximum or minimum point. This is the maximum point. So I'm going to cross this out. It's a maximum point. Half 29 over 4. If you want to put 7 and a quarter. Well, plenty of people will put 7 for this, you know, and get it wrong. Plenty of people will put 7 because they're working exclusively from what they saw in the table. And the highest value they saw in the table was a 7. Well, you have to know that the maximum value cannot occur at 2 different points. It occurs only at 1 point. All right? So, but you know to calculate the maximum value, and that is it. Write down the coordinates of the maximum point. See here? That is it. All right, I think we skipped over that one. All right, so if we continue down here, so we'll do that here. And then now what else I wanted us to do? The axis of symmetry is x equals a half. And so use your graph to find a solution for this. Now, you know what this is giving you? What does this give us, guys? Somebody unmute the mic quickly and tell me. The solution for this gives us what? What do we get when we solve the equation? This equation is giving us the roots. That's the quadratic equation asking us to solve, you know. But because we have the graph, we don't have to solve it. The roots are the x values where the graph intersects the x-axis. So this equation is referring, this equation that they're telling us to solve now, and we have to do it from the graph, is referring to this point where the graph intersects the x-axis, and also this point where the graph intersects the x-axis. So this is to estimate them from this sketch that we have. But the value might be a little bit different. Right? Those are the values that they're asking us for. So if you look at it, if you look at this point, let's look at it carefully now. Here, look at the scale properly. So there are 10 lines, 10 small lines between -1 and 1. And -2, sorry. So it means that each of the small line is 0.1. Because this will be -0, -1. This will be -1.5. This is -2. So it means that this value right here, to me, is about based on what I have on my graph, is -2.2. So 2.3 or so, 2.4, 2.5. So the point is -2.2 right there. So I would put -2.2 for one value, and then the other end Right, here is the other root. It's looking like 3.1 based on the sketch. 3.1. Looking like 3.1. That's what my graph gives me. Maybe it's really supposed to come over and be 3.2, you know, right? Because everything's symmetrical. The distance from here to here must be the same distance from here to here. So I think it should be 3.2. So let's put that 3.2. Just it's a matter of how I draw the graph here. That's part of it. So maybe this is supposed to go a little bit wider, down to 3.2, and come down like that. All right, so let's put that 3.2, because we understand that the graph must be symmetrical. We understand that, right? So I'm going to put it here instead at 3.2. You have to use the knowledge that you have. Let's put that 3.2. Right, so I'm going to put 3.2. But the values are symmetrical over here. 3.2 is the other x value. Where the graph intersect the x-axis. Remember, when you solve the equation, you're finding the x values where the graph intersect the x-axis, which are called the roots. That's what you're finding. So that is the answer for that. But understand that?
Yes, sir.
Yes, sir.
And then this is asking us to do some other stuff, but I'm going to leave out this part, because this part doesn't really relate to the topic at hand, which is the quadratics. It's telling us to draw a line through this point and through this point, and we have to determine the equation of that line. That is coordinate geometry. So I'm going to leave out that part of it. It's not quadratics. So we have completed the quadratics part of this question. We have completed the quadratics part of it. All right, give me a second, guys. What's up? Huh? 200? Wait, not yet. Huh? Can't write it no, in the middle of class. Leave it and me write it afterwards. Huh? Easier? Huh? No, man, I leave it, man. No worries. I leave. Just leave it. Me write it and leave. Yeah, man, I leave it. All right, cool. Yeah. All right, thanks. All right, so about that, guys. I'm at work, so I know sometimes somebody might come in here. All right, so just excuse me. Excuse that. We're doing the class anyway. All right, so everybody good at that? But okay?
Yes, sir.
Yes,
sir.
All right, beautiful. All right. I want us to maybe look at another quadratics question. You know, I know that we also did factorization and, you know, solving the equation by factorizing. We did some factorization while we're doing the quadratics, and that's how we pair the topics sometimes. But I'm thinking that I want us to look at another question that brings about a graph to do something with, so we can understand this thing. Let's look at January 2022. I think there's one on January 2022. All right, so let's look at that. January 2022. Let's see if we see one there as well. 2022 January 2022. Right here. All right. There you go. So another frown. See, different function. But, you know, let's look at it. All right, so let me open up another one. Let's put over here, January 2022. And let me get another one, because we need a graph. Let's get another one. January 2022. Right here. Question 8. So I have the graph on one side and the calculation on the other side. All right. Let's do some of this again. Number 8. So it's section 2. This question is located. See, number 8. All right. So let's do this one again now. Right. More of the same. Another year, another exam. similar stuff, different values. Again, this one happens again to be a frown. All right, and we know it's a frown because the square term is negative, and this is a y-axis intercept. And we have to fill in these values, we have to fill in those values, but again, we must understand the symmetric nature of the quadratic function. And I can know my axis of symmetry already is right in between here. All right, because you see, I'm trying to approach my maximum. I reach 9 and 9, but it cannot be my maximum. So my axis of symmetry is right between here. So the values will extend this way the same from that line, and this way the same. All right. So if I can find one value, because I don't have any of these values repeated. So if I can find one of the values out here, for example, if I can find where I know what 0 gives me 3, and I have a 3 over here. So I'm kind of good. No, I still have to work out one of these. All right. So let me show you what I'm saying. We know that the 0 gives you 3, because 0 is the point on the x on the y-axis. Sorry. When x equals 0, here and here, the y value is going to be 3. So we know that already. We don't have to work that one out. So this value right here is going to be a 3. So this tree corresponds to this tree. When I go to the left from this tree, I'm going to -3. So I go to the right from this tree, I'm also going to -3. So I can tell you that the 6 is going to give me -3. I don't have to work it out, because the values are symmetrical. Right? So these two values are going to be the same, you know. This and this going to be the same. I don't have to work out both of them. I just need to work out one. See, the value between the 9 and the 3 is the same. So once I work out one of them, I know the other one. Now, if you want to work them out just to test them to see if it is correct, you can go ahead. All right? You can go ahead. All right? So I'm going to work out the one for 1. So I'm going to say when x equals 1, and to show the examiner that I know, I can maybe say when x equals 1 and when x equals 4, I'm getting the same value. The pen going, guys. The pen giving me a little problem. Let me see if I can. If it give me a problem again, I'm going to change the mark, the pen. All right. So I'm going to work out for x equals 1. I'm going to get the same value for x equals 4. If you want to try it for x equals 4, work it out. You'll see that you get the same y value. The y value is going to become, because remember, f of x is still a y value now. This f of x is still a y value. It's going to become 3 plus 5 times 1 minus 1 squared. I'm substituting 1 for the x here and there to see what the y value is. This becomes 3 plus 5 minus 1, which gives me a 7. And that is 8 minus 1 is 7. So the value right here is 7. If that value is 7, then this also must be 7. Because the values are symmetrical about that red line, which is the axis of symmetry. So I know before I even start that my axis of symmetry is at 2.5, 2.5. Half in between 2 and 3 is 2.5. My axis of symmetry is x equals 2.5. Let me write it. X equals 2.5. And if I want to know the y value that corresponds to the 2.5, I take 2.5, I plug it in there. Or I calculate the yt. This is actually my xt value. The x value at the turning point is going to be 2.5, the axis of symmetry. I can find the yt value using the formula, 4ac minus b squared over 4a, or I can plug that 2.5 in there for the x and get the y value there. That is my y value. It's going to be my maximum value. If you want to try the 7, let's work out and just show that the 4 also gives 7, just to prove it. The last time I'm going to do it that way. You need to learn to pick up the symmetry and use it. But let's do it. Let's do the x equals 4, just to prove it. So I did x equals 1 right here. Let's do the x equals 4 just to prove it. So the x equals 4 is giving me the same value. So if I put in y equals 3 minus 5 times 4, not minus, plus 5 times 4 minus 4 squared. Work it down. This is 3 plus 20 minus 16. 5 fours is 20. 4 squared is 16. This right here, so it's 4. 20 minus 16 is 4. 4 and 3, 7. See there? This equals 7 just the same. I did not have to work this out because I pick up the symmetry in the values. So the 1 is going to give me 7. The 4 is also going to give me 7 because they are equal distance. Those x values equal distance from the line of symmetry going this way and that way. All right. Hope everybody's picking that up. I want to just pick up that and use that advanced knowledge. Then I want to get the y value at the maximum point. I know that I'm going to need it. All right. So I can do it 2 ways. I can do it by plugging the xt value in there, or I can calculate it with the formula. This is the y value at the turning point, the axis of symmetry. So I'm going to write that x equals 2.5. My y is going to be 3 plus 5 times 2.5 minus 2.5 squared. Let me just use a calculator and work it out since I have it. Let me just use a calculator and work it out. Let's use a calculator and work it out quick and fast. I'm going to work it with the formula next and show you that it's going to be the same value. All right, just for us to understand it. 3 plus 5 times 2.5 minus 2.5 squared. I'm getting 9.25. 9.25. That's 9.25. That's my maximum value. So it means that my maximum point is going to be at 2.5, 9.25. So this question is similar to one that we just did. And of course, the table is not showing a 9.25, but you have to know that the maximum value is not 9. Similar to the one that we just did. Let's work it out with the YT now. Let's work it out with the YT and make this smaller. We didn't have to work this out. Let's make it smaller and calculate the YT using the YT formula. Let's divide it here and use the YT. It's going to be the same as the 9.5 just to prove it to you. Because I want you to understand this thing fully. So the Y value at the turning point, if you're using the formula, it is 4AC minus B squared divided by 4A. Remember now, the A and the B and the C, they are coming from the standard form up here. In this case, let's write them down. The A is equal to -1 because it is a coefficient of x squared. There's no value there, so like there's an imaginary -1 there. Then the B is a coefficient of the x, which is a +5. And the C is a constant term, which is the 3. So remember, the A, the B, and the C is not about where the values are placed in terms of the sequence of how they write out these 3 values. The A is a coefficient of the x squared. The B is a coefficient of the x. And the C is a constant term, whether they put the constant term first or in the middle or last. So even though they put the constant term first, they still give the letter C. All right? Because the rules and the formula that are developed are based on the A, B, and C having those definitions. Coefficient of the x squared term is A. Coefficient of the x term is B. Constant term in the quadratic expression is C. All right? And that's the A, B, and C that we're using down here. So let me just copy these down so we can have them in front of us. So that's the A, the B, and the C right there. And put them in a box. So using the values here now. So the YT becomes equal to 4 times A. The A is -1. Times C. The C is 3. Minus B. The B is just 5. So you're squaring 5 right there. So remember, this minus not changed. It stays a minus. Divided by 4A. 4 times -1. Let's work it out now. YT equals. This now is -12. That's a -12. So you get -12 and -25. divided by -4. This becomes -37. See that? -37 over -4, not 36, -37. The negatives cancel and give me 37 over 4. 37 over 4 is 9.25. 9 remainder 1. Remember, 9 4 is 36. Right? So it's 9 remainder 1. 1 over 4. 9.25. 9.25 is the same as 9.25. If you use decimals. That's what we have right there. So you get the same maximum value, which is a YT value. But understand that?
Yes, sir.
This is just all extra stuff for you to understand it. Remember, the question really require all of this, I'm just doing this extra stuff for us to understand the topic clearly. All right. So let's go forward now. What else I want us to do? They want us to draw the graph. Now, notice they give us some of the points, right? They gave us the points that were on the table, that they gave us on the table. They gave us these points that I'm marking in purple. Those 4 points. Those are the 4 points that they gave you. 1, 2, 3, 4. You have to put in the rest of them that we worked out. All right, let me bring up the graph on the next side of the screen now. So we have the table and the graph looking at the same time. All right, so I'm bringing the graph up on this side. I'll go back for the table here. All right, let me erase these circles now. All right. So plotting the points. So putting on the points that we worked out. So one point that we worked out was the point 0,3 on the y-axis intercept. 0,3. Let me mark those points. Let me mark those points in blue. 0,3 on the y-axis. So the y-axis here, look at the scale. This is 2, this is 4, this must be 3 in the middle. So that point is right here. 0,3 is right there. So I'm marking with that dot. Then we also worked out the point 1,7. 1,7 is another point that we worked out. So 1 here, 7, this is 6, this is 8. 7 must be right here in between them. So 1,7 is right there. Then another point that we worked out was 4,7. 4,7. So 4 here, I'm coming up to the same 7 as that is. So we're talking about right here, 4,7. Then the last point we worked out was 6, -3. That's our point, 6, -3. So 6, -3 coming down in line with this one, that is -3. So we're talking about right here, down here. And I can put in the line of symmetry between them now. Is this line is the line of symmetry on that graph? See? Right between the 2 and the 3, which is the line x equals 2.5. Draw it properly. This line is the line of symmetry for this quadratic function now. That's the halfway line. All right. And the maximum value, the maximum point is at 9.25, not 9. So the person who's going to draw this graph, some persons will make the mistake and come up here, come up through these points up here like that. And then we just jump straight across and then go like this. And that will be wrong. You cannot just jump straight across here. You must recognize that it's a curve. There's no straight line section on the curve. It goes up and come down. But we want it to go up the right place. So let's put on where that point would be. Let me erase back this line of symmetry and put on as a point, the axis, the vertex, sorry. Let's put on a vertex point. We know it's on this line, but it goes up to 9.25. Let's look at 9.25. Let's estimate where 9.25 would be. So right here would be 9. That's why we have these 2 points where they gave us where the y value was 9. See there, these 2 points for 2 and 3. We're looking for 9.25. So since this is 9 and this is 10, right here would be 9.5, halfway between 9 and 10. So 9.25 is halfway between these two now. So you can estimate it to be maybe around here. 9.25. So I'm gonna mark it, and remember it's on this line of symmetry. So I'm gonna mark it right around here. If you do it on the exam, they'll give you your marks. Just make sure you don't come across here when you join the graph. You make sure your graph come up through here and go back down like that. All right. So I'm gonna put that as my maximum point. I'm gonna mark it, max, and it is 2.5. 2.5, 9.25 is my maximum point. Then I'm going to draw my curve now. Draw the curve. All right, draw the curve. So I'm going to go like that. Let's try it this way. Come down through like that. And then come this way. And go like this. It looks so proper. It looks so proper. More this way. Hold on, guys. Hold on. I want to do this properly, you know. Good enough. That's it. That's my sketch. Important thing, as I said, you can't jump across here, so guys. No. You have to realize that it has a single maximum vertex point. But understand that?
Yes, sir.
If I send you the paper in the group, you'll redo the questions. If I send the papers, these two papers that we're doing today, if I send them in the group, you'll redo them and draw the graph and do over the calculation and do them for me. Well, nobody now say yes.
Yes, sir.
Make sure you know and send them to me. You can do it on your tablet, on your device, or if you want to print it out and do it, right? Just these questions. I'm going to send you the 2023 and the 2022 papers in the group. All right, I'm going to send them to the group. If I don't send them, you send a message, send and remind me. All right, let me send them. All right. All right, let us continue. What is the question I wanted us to do, apart from sketching the graph? So this is the sketch part of it. Then it says, write down the equation of axis of symmetry. See it? Same line, x equals 2.5. X equals 2.5. If you want, you could write 2.5 or 5/2, same thing. All right. Then it says, state the maximum value of function. You see it? It is 9.25. Plenty people have put 9 for this and get it wrong. Because they say 9 was the highest value that they saw in the table. But if you don't know, right, what you could do is just calculate your x, your yt. Because remember, we learned that the maximum value is yt. So we could calculate the yt value, which would give you this anyway. And remember, the axis of symmetry is x equals xt. Now, if you never see it from the graph, you could calculate the xt, or we learned it in class, and get 2.5. But generally speaking, when they show you the graph and you are seeing the things, you don't need to calculate something that you are seeing. It don't make sense. Because we said the calculations and the diagrams must be in sync. They must be consistent with each other. So whatever we would get by calculation, the graph is showing us. And whatever the graph is showing us is the same we will get by calculation. So if they give you the graph and you see the results on the graph, then there's no need to go and calculate. There's only 1 mark for them, you know, for each. All right, so that is that. Anything else? Well, this part of it, again, some coordinate geometry stuff, so I'm not going to do that. We're not going to do that one. All right, so let's do another one. More maths equals better maths. Let us do something with some factorization, because you know we have to, you know, factorization is some easy question, section 2, question 2 on the paper generally. Let us still practice. Let us do a question 2, because we were on the quadratics and we did the factorization along the way while doing the quadratics, right? So I'm marking that I need to send it 2020. This is January 2022 and May 2023. I need to send them in the group. All right. So let us look at May 2022 question 2. We want to do the recent papers, because we are preparing for our recent for the exam that the questions are similar to the more recent exams. So we tend to focus on the more recent exams mostly. All right. All right. So for this paper, we're gonna practice some factorization, I think, and so on in section question 2. See there, question 2. All right. So it's a simple question where they gave us this thing to factorize first, right? They gave us this to factorize. Now, because this is a prime, I can actually factorize this quickly enough. I'm going to do it 2 ways for you. I'm going to use a quick method, and then I'm going to use the long method, the AC method. Now, the quick method usually can use when one of the n values prime, whether this is a prime or this is a prime. Because the only factors that 5x squared can have, is 5x and x, Are the only factors. But 4 now can have factors 1 and 4 or 2 and 2. So you see, really so difficult, because it's 5x and x for sure. Then it's either 1 and 4 or 2 and 2. And remember, you're using the values such that your far product and your near product giving you a middle term. Let's just remind of some of the things. Now remember, when the last value, provided that the square term is positive, when the last value is positive as it is here, it means that the 2 signs in the bracket are the same. The 2 signs in the bracket are the same. I want to do the 2 bracket like this to factorize this. The 2 signs in the bracket are the same, and both of them will be negative. This tells you what they will be. Both of them will be negative. This also tells you that the far product and the near product, the sum of them must give you the middle term. The sum of the far product and the near product must give you the middle term, which is the 9x. And that's how we can use that shortcut method to do this. So let me do the shortcut method and show you now. So firstly, I'm going to write down the factors of 5x. I'm in the exam, I'm doing this, right? I might start out with my pencil to start to test it. But I know that the factors of 5x squared is just 5x and x. It cannot be anything. Let me make this larger. 5x and x are the only factors that this can be. All right? I know that now. I need factors of 4, such that my far product and my near product, my far product and my near product must give me 9x. All right? So if I were to try 1 and 4, let me try that away first. If I were to try 4 and 1, then no, not that way. Let me try the other way first. I'll try the wrong way first. 1 and 4. My far product will be 20x, and my near product would be 1x. This is telling me that it is the sum of my far product and my near product that's going to give me a middle term. When I add these, I'm getting 21x. So it means that the 1 and the 4 can't work that way. Can't work that way. I would have to switch them around and try the other way around. So I put the 4 here and the 1 here. Then if I go this and this and this and this, then this is 5x and this is 4x. 5x and 4x add up to 9x. So it means that the values can work that way. The values can work that way. The 1 and the 4 can work this way. And then now, remember now, the signs in the bracket are both negative. Oh, I know. Because this plus out here means that the 2 signs in the bracket must be the same, and this is what they must be. They must be negative. So that's my answer now. That is it. I factorize it correctly. Because see, my far product is now minus 5x, and my near product is now minus 4x. The minus 5x and the minus 4 gives me my middle term. If you want to double check everything, then you can see that 5x times x is 5x squared. Then negative 4 times negative 1 is positive 4, my last value. And then as I said, no, the middle term is always the far product and the near product. And if I tried 2 and 2, because the other factor I could try was 2 and 2. So if I tried 2 and 2 instead of 4 and 1, then my far product would be 10x and my near product would be 2x. These add to 12x, but my middle term is 9x. That means that it cannot be 2 and 2, right? So that is why it is so easy to factorize. So the correct answers is that I must put 4 here, 1 here. Signs are the same. They are both negative. Minus, minus. That's it. Well, let's do it the other way now. Let's do it the long way now. So if you learn the shortcut method, guys, I've explained to you in class, then you can actually factorize this in one line like that, especially when one of the n values prime, as it is here. It becomes easy when one of the n values prime. All right, so let me write the answer up here beside it. We worked it out, and it is the r above it. It is 5x minus 4 times x minus 1. Those are the two factors. And if you write the other way around, x minus 1 times 5x minus 4 is still correct, right? Still correct. Just that the factors are written the other way around, but it is still correct. All right, let's do the long method now. So the long method is when we're basically trying to break the quadratic out into 4 terms. So we can factorize by parts. And you do that by trying to split this middle term of negative 4x. The process involves the calculation of what we call AC. This is the A and this is the C, right? The plus 4. So multiply the n coefficients. The 5 times the plus 4 gives us 20. They were looking for factors of 20 that add to the middle coefficient of negative 9. Factors of 20 that add to negative 9. All right. So here now we're looking for factors of a positive 20 that add to a negative 9. Factors of a positive number that this is either 2 positive numbers or 2 negative numbers. Since I want the sum of those 2 factors, which must have the same sign, to be negative, I have to use 2 negative factors of 20. That is 4 and 5, you know. But let's say I don't say it's 4 and 5. You can go down the list of factors until you find them. So let's say I didn't know. I'm going to go for the first 2 factors of 20, which would be 1 and 20. And both of them have to be negative. Those are factors of 20. Both of them have to be negative because I want the sum to be negative. But these 2 right now add to negative 21. I don't want negative 21. It is negative 9 that I want. So I go to the next 2 factors of 20, which is 2 and 10. I'm trying to find it. Again, both of them have to be negative because I want factors of a positive number. Both of them must have the same sign. And so they must have the same sign as this one. But these 2 now add to negative 12. But my middle term is negative 9, not negative 12. So I can't use this one. If my middle term was negative 12, then I would use these. So I go to the next 2 factors of 20, 3 and what? No, we're not going to use 3. We are looking for whole number factors. So go to the next factor after 3. The next factor to try after 3 is 4. 4 and what? 4 and 5 are factors of 20. 4 and 5. Make both of them negative. And negative 4 and negative 5 is actually negative 9. So yes, we have found it. It means that we're going to split this negative 9x into negative 4x and negative 5x. Or we can put the negative 5x in front. So I'm going to split this. Split it. I'm going to split it into negative 5x and negative 4. I'm putting negative 5x in front because I want it to factorize nicely with the 5x squared. So I'm ready now to split the negative 5x. Let's do it in blue. So let's do it in purple. Purple. So this 5x squared comes back unchanged. Then the minus 9x, I'm splitting it into minus 5x and minus 4x. This tells you what you must split the minus 9x into. That's what it is all about. All right, so I'm going to split it into minus 5x and minus 4x. The reason I put the minus 5x before the minus 4x because I want to set up a nice factorization with the 5x squared there. All right, And then now I'm going to put back the plus 4 out here. Plus 4. And when you reach here, so you must always check that what you split into will give you back what you had before, which it would, just in case you made a mistake. Always do that check. All right. Then now we're going to do factorization by part. So like we're factorizing these two terms. And we're not only looking for a common factor, we are looking for the highest common factor of those two terms. In this case, it is 5x. We're going to factorize 5x out of those two terms. So 5x factorized out of this is going to give me an x. 5x factorized out of this is going to leave me with a negative 1 in the bracket. And what it is that when we're factorizing this way, this method, you must have the same bracketed term here as well. So what I normally do to ensure that we have the same bracketed term there, I put back the same bracketed term first, the x minus 1, because I want to ensure that I have the same thing in the two brackets. And then to find out what goes in between here now, which is always plus a value or minus a value. Never just a value. It's either plus something or minus something that must go in between here. I can divide this 4 by this negative 1, which gives me negative 4. So I put in a negative 4 there. Or I could divide this negative 4 by this x. Same thing, I'm going to get negative 4. Anyway, you take it, I'm getting a negative 4 there. Don't just put 4. Because if you put 4, when you're ready to write the next line, you might just put 5x plus 4 in the bracket in front of the x minus 1. So you have to put that is a negative 4 you need there. So you don't make the mistake of putting a plus 4 in the bracket there in this case. All right, I'm telling you the mistake. And then now the x minus 1 is a common factor. So you're going to put these two together with a common factor. Right? So it becomes 5x minus 4 times the common factor now of x minus 1. And that is it. Or if you get them the other way around and put the x minus 1 in front of the 5x minus 4, that is still correct. Same thing. But that is it. Any questions there, guys? This is a shortcut easier than to do all of this. Shortcut easier. So we need to learn the shortcut. We need to practice it and master it, especially when your n values are prime. An easy number like 4 that only has factors 1 and 4 and 2 and 2. Easier. You just need to understand the plus and the minus thing out here. You understand those things. Like the positive out here means that the signs in the bracket are the same. And that it is the sum of the far product and the near product gives you the middle term. Learn the shortcut method. All right. Next part down here now, say hence, solve this. The hence means that we must use the factors that we got up here to solve it. That's what the hence mean. Use the previous result. Don't go off and try to solve this another way. Because the question only said hence. It only said hence. If the question said hence or otherwise, it means that we could have, for example, used the quadratic formula as the otherwise method. But since it says hence, it means that it wants you to use the factors to solve this by factorization. So we're going to use it. So this expression, when it's factorized, it becomes 5x minus 4 times x minus 1 equals 0. So remember now, solving this is as if it is a 5x minus 4 equal to 0 or the x minus 1 equal to 0. I can write the answer from here, but I can still put the line 5x minus 4 equals 0 or x minus 1 equals 0. One of them must be 0 if the product is 0. If this times this equals 0, then either this is the 0 or this is the 0. That's what we're basically saying. Now, if this one equals 0, what is the x? Transpose the negative 4, get positive 4, and then divide under the 5. Easy as that. So the x will become 4 over 5 from this one. Or, in this case, we take the negative 1 and transpose it to leave x alone as a subject. And so we will get x equals 1. So those are your roots. Those are the solutions. X equals 4 over 5, x equals 1. I did not have to write this line. Not absolutely necessary. But I write my solutions straight from here. See, it's only 1 mark for written for the answers. All right, that is that. All right, I'm not gonna do this because it's something different. I'm just looking for quadratics and factorization. So that's it on this question, guys. That's it on this question. Let's do another one. Let's see if we can find one more graph on. What do you think? What time is it now? We have about 7 more minutes. Let's do one more graph one. We can find one more graph one to do, and then we can call it a day. All right, we'll do more factorization as we go. Let's look at another graph one. Hold on a second. Let me answer this call. Hold on. Hello? Hello? Yes? Which link are you using to get to on YouTube? All right, I tell you what, it's being, yeah, try it on YouTube. Let's go on Raffication. We're basically finishing up now, but the video will be there on YouTube. You can rewind it and watch it. So we're gonna finish up shortly, and then you can call me back and I'll give you the link to YouTube so you can watch it. It's gonna be there. All right. All right, cool. All right, guys, sorry about that. Let us do one more. So we have it a 2-hour session. Let us do one more from June 2021. Another graph one, 2021. Let's see. And this is June 2021. One more. Everybody okay so far? Everybody all right?
Yes, sir.
Yes, sir.
Right, good. June 2021. All right, let's see what question it is. Question 8. So there's another section 2 question. So this is some graph again. So you see the nature of these questions. Some of them ask it to compare square to what we did last week. This week, now we're focusing on the entire thing. And there's yet some other ways that they set quadratic questions, and we practice them as we go. All right, because we still have some more quadratic stuff to do tomorrow. All right, we have some more quadratic stuff to do tomorrow. All right, 2022 8P. All right, see another one here. Let's see this one in a sense. So this one I give it in all the values. It was all the values, so we're not required to calculate any of the values. And it gave us some of the values on a graph. It's a smile graph. And then that's all I wanted us to do, to draw it. All right, so I guess this one is testing our knowledge that the axis is somewhere in between here. Right, so this is -4, -4. So the axis is -0.5. Halfway between 0 and -1 is 0.5. It's going to ask us for maximum or minimum. This one's going to have minimum because the square term is positive. All right, let's do it. Let's do it. More math equals better math. Let's do it. All right, let's bring it up over here. 2021. And let's do it. Let's do it. Let's just do this one and then we'll call it a day. All right, 2021. Let's go up and get another one over here. Right, let's just do this last one, and then we'll call it a day, and then we'll do more quadratics tomorrow, as I said in class, right? The next part of it. Tomorrow is the last quadratics class. Finishing off the topic tomorrow. All right, finishing off the quadratics topic tomorrow. All right, so this is the same question here now. So I think we're gonna put the graph on this side of the screen and draw it there. All right, let's see. So this one, they didn't have to calculate any value. They gave us all the values except that we must recognize that it's a smile Because square term is positive, so it's going to shape like that. It's going to have a minimum point, and minimum point is somewhere below 4, -4 mean. And it's at a value where x is between -1 and 0. Halfway between -1 and 0 is actually -0.5. -0.5. So we know that based on this axis, the xt value, x value turning point is -0.5. So to get the yt value, we could take -0.5 and plug it in there, or we can calculate the yt the normal way with the formula. All right, so this one says write down the maximum or minimum value. It's a minimum, so I'm cross out the word maximum. It is a minimum. We can literally calculate it two ways. We can say it is a yt value, which is 4ac minus b squared divided by 4a. A lot of people put -4 in, guys, which is wrong. The minimum value cannot appear at two different points. It only appear at the vertex point. One vertex point is where the minimum value occur. All right, so we can calculate it this way, the formula. That will be 4 times a from this to a is equal to 1 times c. The c is -4 right there, -4 minus the b. The b is a 1 in front of the x, so it's -1 squared divided by 4 times a. The a is 1. Now this is -16 and -1 is -17. This is -16 and -1, -17. -17 over 4. That's -4 and a quarter. -4 and a quarter, or -4.25, -4 and a quarter. That's what it is. Is the minimum value of the function, the yt value. If you want to we can calculate by plugging the xt value in the function here as well. That's another way to do it. So we could say, or the y value turning point, which is the minimum value, would be -0.5 squared plus -0.5, you want to put it in the formula, minus 4. If you use a calculator to work it out, just to show you, we're gonna get the same thing. This is just to show you guys. This is just to show you. Bracket -0.5, close bracket. We're squaring that, and then we're really subtracting 0.5 because the plus minus right here is just minus. And then if we subtract 4 again, you get the -4.25, right? 4 and a quarter, -4.25. Same as this, -4 and a quarter. So that's the minimum value right there. All right. It says using a ruler, draw the axis of symmetry. So I want us to draw the axis of symmetry. We didn't plot these points yet enough for part 1, you know. We need to plot the points of part 1. We'll go back from the graph and plot the points of part 1 and put the axis of symmetry. Just put in the points on the graph over here. So we have some already. It's all symmetrical. So they put on this half of it, apparently. It was 4 over here. And they put on the 4 on the right side over here now. It's basically the same values, right? Same y values, and they're symmetrical. So we're gonna put 1 here. This one is 0, -4, which is here. The axis of symmetry is this line, right on between here. This is the axis of symmetry they want us to draw with a ruler. X equals -0.5. This line. But I wanted to draw it with a ruler, guys. X equals -0.5. That is the line of symmetry right there. We'll put in other points. The next one is 1, -2, which is right here, which corresponds to this one. It is symmetrical with that point. The next one is 2, 2. 2, 2 is right here. It's symmetrical with this point. And the last one is 3, 8. 3, 8 is here, up here. And that one is symmetrical about the line of symmetry at that point. All right. And then remember now, our minimum point is -4 and a quarter. So we need to put in that 4¼ properly. Let's look at the y-axis scale. See y-axis scale here. Let's look at it. This is -3, -4. So right here is -5. So right here is -4.5. Let's mark it in red. Right here is -4.5. So right here is -4¼ around here. So around there. So -4¼ So I'm going to mark that. So this point is my minimum point, which is -0.5, -4.25. That's my minimum point right here. And I'm going to draw the sketch in blue. Let's draw it in blue. So it's going to just come down nicely to these points. Make sure it come down here and turn at that minimum point there. And then it goes back up and it is all symmetrical. Don't use any ruler, draw it with a free hand like that. All right, as best as I can. Practice it, and you'll be able to do it easily. Let's practice it. That's the curve. That's the curve. And the axis for the axis of symmetry, the axis to show it, right? Using a ruler, see it here. Draw the axis of symmetry. That's this red line right here. I see this time I spend symmetry 2 M's. No problem. This is the axis that I'm talking about. I want us to draw axis of symmetry. And anything else? No. Question done. Question done. All right. What time is it now? 1:05. So basically, it's been going for 2 hours, guys, and that is what we were committed to today. Anybody have any question? Anybody good? Everybody
Yes,
okay?
sir.
Yes, sir.
Yes, sir.
All right, so I'm gonna send these papers to the group, guys. I'm gonna send 3 papers. How many papers with it? 3 or 4? With 4 papers, right? Today. I'm gonna send to the group. I'm gonna send May 2023, January 2021. No, January 2022. I'm gonna send May 2022 and this one, July 2021. I'm gonna send them to the group right now. All right, and the video is on YouTube. This video is not gonna be on the Zoom, but I'll send the link still in the group so that you guys can go back, watch over the video, retry the questions, do the questions over again, pause, rewind, and play. Make sure you can write the question by yourself. Moving on to something different tomorrow. It's more quadratics, but moving on to some other aspects of quadratics tomorrow. Tomorrow we're going to be focusing on how do we get the function given the roots. So we're working backwards from the roots to the function. And secondly, we're going to be doing simultaneous equations that lead to a quadratic equation. That's what we're doing in class tomorrow. And those are the things we revise next week, Saturday. Again in this session, that's a plan to revise what we're doing tomorrow, next week, Saturday. All right, but you have classwork and stuff on it on Wednesday. You know the program already. All right, so that is the plan, guys. So I see you all tomorrow. Tomorrow and Monday. Some of you coming Monday for us to do those, finish off with quadratics. All right, and next week we're going on a new topic next week. But let's finish off the quadratics in style, starting tomorrow. All right, bye. Okay, guys.
All right, later, sir.
All right, cool. All right, bye, everybody. Go over the questions and send them to me, please. Let me know that
Bye,
you did.
sir.
All right, bye-bye. Bye, everybody. Bye.